Assalamualaikum to my dear panel and my supervisor. My name is Amina Tasha bin Yusuf and I'm from Bachelor of Computer Science in Level with Honors. My supervisor is Dr. Muhammad Daniel bin Zakaria. Today I would like to present my final project, performance analysis of key variance vectors over MANET routing protocol. In the abstract, MANET is considered an autonomous collection of wireless mobile nodes that are capable of communicating with each other without the use of a network infrastructure or any centralized administration. TCP is the dominant end-to-end protocol on the internet today, but face a congestion problem in some cases. To determine the best variance and solve the congestion problem, we propose to study TCP vectors on AODV protocol in MANET with three performance metrics: throughput, average end-to-end delay, and the packet delivery ratio. For the simulation result, get end-to-end delay show the decrease the end-to-end delay. Packet delivery ratio has a linear delivery rate, and also we compare the throughput performance of TCP and TCP vectors with a congestion avoidance solution. We calculate the expected throughput rate and actual throughput rate on the round time. For the problem statement, the enability of a standard TCP to detect the packet loss in wireless network is to float it common, and the throughput degradation, such as a backline, misinterpretation of the packet loss and the congestion window over network congestion. For the objective, to study the performance TCP variant over MANET to simulate the implementation of TCP vectors for AODV protocol over MANET NS2, and to evaluate the performance TCP over MANET in terms of throughput, packet delivery ratio, and average end-to-end delay. For the framework, from MANET, we simulate in AODV protocol, and we evaluate the TCP vectors and the TCP variance because TCP vectors is detect the conjunction without wasting time, and TCP vectors is used for solve the conjunction. And for the OTCS script, we use NS2 Ubuntu. For NS2, we can trace file, trace num file, and when we generate the trace file, we NS out script to calculate the performance metric, and we plotting program SCAR and GNAplot for performance metric, average throughput, end-to-end delay, and the packet delivery ratio. From the result, we use a 50 number of nodes in NS2, and this is a graph for packet delivery ratio, and this is the graph for average end-to-end delay, and this is the graph average throughput of TCP and TCP vectors. The last is contribution. We can compare the TCP and TCP vectors in throughput. That TCP vectors is used for creation the difference between expected and actual throughput that may avoid the conjunction, and we can evaluate the three performance metrics in AODV routing protocol over MANET. That's all from me.
This is video demonstration for my final year project. To calculate the performance metric, we need TCS script to generate AODV TCP vectors scenario. And this is TCS script. As you can see here, they have 50 number of nodes and use AODV as routing protocol. For command NS, First, at the one for choose a audio protocol, the one for TCP Vegas. As you can see here, we successfully generate DCS grid and also non-trace file. Now we can see here the mobile node is moving and the packet is delivery between source and destination. To calculate the, pack the packet delivery ratio, use got command of script and AODV Vegas DRS transfer. So for the first row, we can see here the time cycle, and the second row is the second for packet delivery ratio. For end-to-end delay calculator, for the first row, show the second, and the second row is show the second for the end-to-end delay. And lastly, for the throughput calculator, as you can see here, for average throughput is 71.36 KB per second, and start time is 1 second, and stop time is 49.96 seconds. Packet delivery ratio is packet delivery ratio is as grid. We set S label as time and set Y label as packet delivery ratio. And now we run the DCS script for generate the graph packet delivery ratio. Wait for 3 seconds and we can see the graph in the RP folder. Now we can see the graph of packet delivery ratio. The result show of 10% at 30 seconds is increased linearly to 100 at 15 seconds according to the simulation result. Now we go to the end-to-end delay file. As you can see, this is end-to-end delay TCS script. Now we set S label as time second and set Y label as end-to-end delay second. Now we run the TCL for graph end-to-end delay. Now wait for 3 seconds and it shows successful and the graph are in RP folder. Now you can see the graph of end-to-end delay in AODB routing protocol. And the average result show Vegas is decreased range for 0.08 second to 0.01 second. The reason is Vegas is detect congestion faster at an early stage without wasting time waiting for a packet loss. Now we run the Gina plot. Fine. Now we can see the Gina plot graph for throughput, TCP, Vegas, and TCP. Based on the performance analysis, we can see they have two lines, which is the purple line, it show for TCP, and the green line, it show for TCP Vegas. To compare with this line, TCP has a congestion window during packet retransmit to the destination. And we use TCP Vegas to solve the conjunction because TCP Vegas is detect conjunction at the early stage without wasting time to packet loss. And to overcome the problem, we use TCP Vegas throughput algorithm on the right side. I think that's all for me. Thank you.